So let's start. Let's start the Ocean Thermal Energy Division Research Project. My name is Yasuki Hidegami. So Ocean Thermal Energy Department is maybe two divisions. So one is system integration research and heat exchanger. System integration research project is by me and Professor Morisaki. And heat exchanger part is leader is Professor Arima. So later I would like to explain this project. So our OTEC division is mainly five main topics, research topics. OTEC whole system and heat exchanger and anti-biofouling for the heat exchanger and condensation and evaporation design and phenomena analysis and multi-use deep seawater application. So our institute competition in the 2003. So in this satellite, the mainly OTEC hybrid system, using imari-based seawater to go to the OTEC, then desalination system and lithium recovery system after use desalination, and seawater simulation and hydrogen production using OTEC electricity and desalinated water. So we have a system is ammonia water mixtures turbine, 30 kilowatt, and the monitoring system, the turbine and evaporator, condenser, tank is a two-stage cycle. So we have a three working fluid pump. So recently, post ammonia water mixture cycle, so we are now promoting a double-stage ranking cycle. So double-stage ranking cycle, same heat transfer area, we divided two systems. So this double ranking stage cycle is including the output power, like water ammonia mixtures. So this area we can increasing the net power, output power. So we have supported NEDO project. So we constructed two-stage Rankine cycle system. So and we have a project, JST JICA SATREPS project with Malaysia UTM Malaysia University of the Technology of Malaysia. So until last year, March of 2025. So overall goals, the implementation of the combination of the hybrid OTEC and the deep sea water application so-called Malaysia model, the commenced in Malaysia. So as you know well, heat exchanger is called biofouling, and especially the evaporator side. So this issue is will be changes depends on the site. So we want Malaysia has a huge potential, so we want to solve this issue for the operation of TEC. So not to use the surface water directly, this hybrid OTEC. So we propose this system. Hybrid OTEC system is this side is OTEC. So this side is desalination. OTEC site is already a success in Kumejima. Desalinated site is already success in India. So as a one system, we want to realize a hybrid of this system. We want to get electricity and desalinated water. So in this project, main research is a new type heat exchanger. This heat exchanger not only evaporator and seawater. This side is pure water. After desalinated water, so we can evaporating the ammonia. So in this project, we realize this hybrid system. So this project is Japan side is Saga University, Tokyo University, IOES. Malaysia side is leader is UTM, or totally 5 university on the Malaysia side. So in this project, we have constructed this new OTEC laboratory in Malaysia. Port Dickson is close to the Kuala Lumpur. So we installed this hybrid OTEC constructed in Japan, so we moved to the Malaysia. So we installed this success in this system. So last January, so we hold a launching ceremony with the ambassador in the Malaysia and the Minister of the Education of the Malaysia government. So after this success opening ceremony, we opened this OTEC facilities as an open facility. So if you want to use this facility, please submit the application to our institute. So next, we want to introduce our heat exchanger development. Under the NEDO project, we developed a new type heat exchanger. Normally is a very smooth heat exchanger, but we have developed the pop dot with some roughly the heat exchanger. So this knowledge is a very old knowledge, including the rough surface. So but some another case is a very increased cost. By the way, with the Kobe Steel Company, we Saga University developed a low cost this surface. So immediately we can make this surface profiles control transfer capacities. So we evaluate the heat evaporator side, condenser evaporation heat exchanger and condensation heat exchanger. But we have two types. Port dot heat exchanger and herringbone type. Port dot heat exchanger is increasing 20% the smooth heat exchanger. Condensation is herringbone type is increasing over 20% the performance. This meaning is promoting the decrease of cost because reduce the heat exchanger required area. So totally we have tested heat exchanger as a herringbone. We developed the herringbone type and normal type. So increasing 26% heat transfer improvement. So this means that we expected over 20% decrease heat exchanger cost. So double stage, as I explained, double stage Rankine cycle. So we applied Kumejima model or Kumejima OTEC plant. This system is using double stage Rankine cycle and a new type heat exchanger. So we can evaluate the net power efficiencies. This using the system improves the performance about over the 10%. So using this heat exchange, this plant, we Kumejima demo system. So next is a commercial system, 1 megawatt and 10 megawatt. this small OTEC system is not economically, only demonstration. So, by the way, using this data, we design the commercial scale. So, if you want to collaborate this OTEC commercialize, we want to discuss this using this data. So we are designed, this is a heat exchanger, so it's a special case, special heat exchanger for the OTEC. So we are designed 1 megawatt, 10 megawatt OTEC. So we are already designed, completely designed in detail. Or 1 megawatt OTEC on type, floating type. Next is the heat exchanger research, Professor Arima. Professor Arima has an experimental apparatus for the evaluation heat exchanger. So this is the test session. So some material is using titanium, aluminum, so on. So he tested this heat exchanger. So now Professor Arima is challenged to that this is optimal configuration and optimum coating. So next, our group is promoting the byproduct using the OTEC, not only electricity. So fresh water, then hydrogen, and the lithium recovery, food, local areas, chilling system. Recently, the data center company very interested deep sea resources, so agriculture, cool greenhouse plant. So one project is a Takumi project until now. Is this leader, Professor Ochi, prefers Tokyo University. Former Tokyo University. So he is promoting the Marine Forum 21st project. In this project, 100,000 tons per day using deep sea oil. So this project using deep sea oil and warm sea oil after mix discharge. So this we expected to recover the fish resources, because deep sea oil including the nutrient for the promoting the fish resources. So this is the actual operation in the Sagami Bay. So in Saga University, we want to contribute to this project using our ocean water simulation system. So this is this Saga University Imari satellite. We have using the ocean simulation. This water simulator, we can control this is the temperature profile. So after the temperature profile, discharge phenomena, we can analyze this. Of course, you can expect it, predict the phenomena using computer simulation. So by the way, this is a system that we can research the actual phenomena. So if you not temperature profile, so this is a random profile discharge, but this is contributed. This is a phenomena. And lithium is recently the lithium is very important for the promoting the electric vehicle, mobile, so on. By the way, in Japan is not use lithium naturally, so only seawater. So recently, as some countries stopped imported lithium, so some project problem to the in Japan the industries. So Saga University has a lithium recovery system. So this is a adsorption material is developed by Professor Yoshizuka. He is last year retired. Now he is a visiting researcher institute. Now continues to collaborate. If you want to use and challenging these facilities, please contact us. This is a system, so actually we can get the lithium. So the lithium is very rare, 0.003 weight percent. After concentrate control the lithium, so we can times 33 times totally 11,000 concentration percent. So this success, so we are now contributed to some project. So economic cost now keeps higher than imported material, but now very reach to the commercial stage. But not yet is not commercial stage, but now more reach to the this next stage. Thank you for attention.